So, if you're a senior architect, you know this headache all too well. You've built an absolute masterpiece of a multi-cloud application, but you're still chasing latency SLAs. How in the world do you guarantee performance when your system is spread across the globe's top cloud providers? Well, let's break it down.
You have done everything by the book, right? You've picked the very best services from AWS, Azure, and GCP. Every single one of your dashboards is glowing green, reporting just phenomenal speeds, and yet your users are complaining. It's this frustrating, really common mystery, and today we're going to crack it.
Okay, so you're a multi-cloud architect. You have built this amazing, best-of-breed system that plays to the unique strengths of each major cloud. And on paper, it looks perfect. It's a work of art.
So maybe your architecture looks something like this. You've got your web tier running on AWS, your business logic is over on Azure, and your data layer sits comfortably on GCP. I mean, each component is a best-in-class choice, so where on earth is the performance bottleneck hiding?
Here's the thing. The issue isn't inside your cloud environments. Your AWS, Azure, and GCP instances, they're probably performing exactly as they should. The real performance killer, the one your standard tools completely miss, is hiding in the gaps between them. And this is what we call inter-cloud latency. Just think of your cloud services like supersonic jets. They're incredibly fast on their own. But what about the time your data spends on the tarmac, waiting to transfer between those jets? That's the layover, and that's the inter-cloud latency that's grinding your entire application to a halt.
See, your standard monitoring tools are fantastic at looking inside each provider's walls. They give you these deep, amazing insights into your EC2 instances or your Azure functions. But they have a total blind spot for the network paths that connect them. To really see the full picture, you need true end-to-end monitoring.
Let's just trace a single user request for a second. It hits your AWS web server, which then calls your business logic over on Azure. Azure then needs to pull data from GCP. Every single one of these hops introduces a tiny, almost invisible delay. That's our inter-cloud latency. And believe me, those milliseconds stack up really, really fast, turning into noticeable lag for your user. So if our current tools can't even see the problem, how are we supposed to fix it? Well, we need to change how we look. We have to make this invisible latency tangible, measurable, and most importantly, actionable.
And the solution is something called synthetic monitoring. Now, this isn't just passive listening. It's an active, proactive approach. We actually simulate those critical user journeys, those AWS to Azure to GCP paths over and over at regular intervals. And this lets us measure the performance of the entire transaction and, crucially, find problems long before your users ever do.
And just like that, the problem isn't some vague slowness anymore. It's concrete data. Look at this. We can see plain as day the connection between AWS East and Azure West is taking 210 milliseconds. That is a clear violation of our 100 millisecond SLA. This is the smoking gun we've been looking for.
With this kind of visibility, the entire game just changes. We are no longer scrambling to react to user complaints and putting out fires. We're now in a position to proactively optimize our architecture based on hard data.
And this is such a crucial mental shift to make. An SLA alert isn't a failure. It's not bad news. It's a precise data point. It's a clear signal telling you exactly where you have an opportunity to make your architecture even stronger.
So what do we do with that alert? We optimize. The data immediately points us to concrete actions. That 210 millisecond latency between AWS East and Azure West? Well, the first step is to model the impact of co-locating those services in the same geographic region. We can now make these intelligent, data-driven trade-offs between cost, performance, and redundancy.
And when you can do this consistently, the whole conversation changes. This isn't just about network monitoring anymore. You're using precise performance data as a form of business intelligence to build a faster, more reliable, and, at the end of the day, a more profitable product.
And the impact here, it's not theoretical. It's dramatic and it's measurable. As this chart shows, once you begin proactively monitoring and optimizing those intercloud paths, the number of SLA violations just plummets. You are actively preventing problems from ever even reaching your users.
And that is the ultimate goal, right? By making that invisible space between your clouds visible, you can finally move from just hoping for good performance to actually guaranteeing it. You can stand behind your SLAs with total confidence because you've got the hard data to back it all up.
So the real question isn't if you can find these hidden performance gaps, but what you're going to do once you find them. You've built an incredible multi-cloud system, and now you have the tools to see its final hidden frontier. How will you use that insight to make it even better?